that's, oh, there we go. Okay, let's see. All right, kids, here we go. We're going to try this from the classroom. I have my mask on, so I may sound odd. Section 1.2, practice question 2. It says a curling rock leaves a curler's hand at a point 2.1 meters from the end of the ice and travels southward. So we're going to draw a picture here. So here's the ice right there. I'm using my finger. Don't laugh, Josh. All right. And this is the end of the ice. So right here is what I'm going to call the 0 point. I got a tablet I can bring from home. Stuff they buy for me don't frickin' work. This is the 0 point. So this is what I'm going to call position 0, or my common. I talked about this in a note. Now, if you didn't read or you didn't watch the video, well, then, you know, you're behind the 8 ball here. This is the common. I'm writing very slowly because my stylus is not working. I'm not having a stroke. This is the common reference. Ooh, I spelled that wrong. It's painful to do it like this. Oh, wait a sec. I might have something in my briefcase. Hold on there, kids, on the video. Maybe this will work. Common. Oh, yeah. Reference point. That's my common reference point. So a curling rock leaves a curler's hand at a point 2.1 meters from the end of the ice. So the curling rock starts right here. So this will be my initial position right there. And I'm going to call it 2.1 meters. And they're telling me that the rock is going to move in a south direction. Okay? So that's telling you that this direction here is south, that way. And this is where the person who's pushing the curling rock begins. You understand curling rock? Okay. From the end of the ice and travel southward. What is the displacement from its point of release after it has slid to a point 9.7 meters from the same edge? So that means a little bit later in time, the rock starts here, but a little bit later in time, the rock is right here. So now the rock's position is 9.7 meters south. Okay, so the rock started here. But now the rock is here. So I want to find the displacement. Well, I gave you an equation for displacement. Displacement is final position minus initial position. That's the equation. I gave it to you in your notes. It's in your video. It's in the textbook. You got to keep up. Now, I know you're not supposed to write two equal signs on the same line, but I'm running out of real estate here. So, final position is, they tell me right there what the final position is. So I put that in. 9.7 meters south. And I put it in a bracket. I keep everything in a bracket. Minus initial position. 2.1 meters south. Oh, don't do that. Go away. How do you make this thing go away? Clear. Go. There you go. South. So now I subtract 9.7 minus 2.1 is 7.6, right? 7.6 meters south. That is the displacement. Now, I can actually draw that displacement vector right on here. Watch. Displacement vectors go from initial position to final position. There it is, right there. I've drawn the displacement vector. And it's represented by 7.6 meters south. That is the displacement vector. And that's what they want us to calculate. Okay? That's the way that works. We're going to stop our recording, but I think I'm